Hi, Accelerated Algebra 2. This is our second lesson, 1B. So let's see how we do. Move that out of the way. We're going to be solving inequalities to remember greater than, less than, and things like that, and graphing the solutions. We're going to solve and graph the inequality and graph the solution, express the solution in interval notation. So interval notation would be when we use, say, a square bracket, or a rounded bracket or something like this, or it could be like this, or it could be like this. And you're like, what does that mean? We'll see. Let's take a look. Solve the inequality, graph the solution, and express the solution as interval notation. All right, so let's go ahead and solve this problem algebraically. A couple ways we could have done this. I could have divided both sides by 2. Typically on this type of problem, though, is you would distribute over the parentheses. 10x minus 16 is greater than or equal to 8x minus 6. We're going to bring the 8x over by subtracting 8x from both sides, so just simple algebra 1. And I think at this point we can just go ahead and add the constant over here. So let's cancel out. Those cancel out and those cancel out. So I get 2x is greater than or equal to 10. Divide both sides by 2, so I find that x is greater than or equal to 5. So that's great. So we want to do this interval notation. So if we graph the solution on a line, if you had 0, if this is a number line, and you had 5 here, remember, because of having the underlines, it would be a solid dot, and we want values greater than it, so it would go that way. And there's other ways we could shade it, but we wanted to write it as interval notation. So the interval notation is, do we include the endpoint? If we do, square bracket. 5 goes in there, comma. And where is this going to? Well, it's going off to infinity. And we never can reach infinity, so we make that a rounded bracket. So this is the interval notation for the solution to our problem. And yes, we do want you to do that because that will indeed help you out with calculus and things like that. Cool. All right, was there anything else on this page? Ooh, I guess we had all the information down below I could have written, but I did it upstairs. Sorry about that. Solve each inequality, graph the solution, and then express the solution in interval notation. So again, remember we're going to distribute over the parentheses, so negative 3x minus 12 is greater than or equal to 2x plus 13. Okay. We want to get x by itself, so I'm going to subtract 2x from both sides. And typically you want to have the x on the left side, and then add 12 to both sides. So what's going to take place for this problem? The 2x's are gone, the 12's are gone. I get negative 5x is greater than or equal to 25. Divide both sides by negative 5. Now, you have to go back to algebra 1. Remember, if I divide by a negative, what happens with the signs? It flips over, right? So that flipped over. See the flip? This is going the opposite direction as this. So if you multiply and divide to get the variable by itself, and you're multiplying and dividing by a negative to get the variable by itself, then the inequality sign flips over. So if we wrote this on number 9, I know there's stuff below, but I'm just doing this. I got 0 here. I have negative 5 here. Okay, do I include the endpoint? Well, yeah, that's a equal sign. Then I want values less than it, so I want values that are going to the left. And notice I shaded it this way. I know on the last problem I did it that way. What's the right way? Your choice. So, interval notation. I'm going to read it left to right like I read a book. So I'm coming from negative infinity, comma, I'm going up to negative 5. And it's a square bracket at the negative 5 because we had the equal sign with it. So here's our interval notation. And again, I know I probably could have done this down here, but I didn't follow directions well as a kid, so there's your excuse. Okay. All right, let's take care of this one. This one's a little trickier. One thing that we have to make certain of, and I'm going to highlight it, is what am I distributing over the parentheses? It is highlighted right now, so it should tell you. So yeah, that negative 2 has to go to both of those. So I get 3x minus 2x minus 10 is less than x plus 6. Let's be nice and neat. Let's combine like terms. So I have like terms over here. So 3x minus 2x is 1x, and I can just list that as x minus 10 is less than x plus 6. So let's start figuring this out. So look at this. What's going to happen here? Uh-oh. Oh boy, what happened on this problem? So those cancel, those cancel, those cancel. If everything on the left cancels, that's 0. 0 is less than 16. Is 0 less than 16? Yeah, that's a true statement, right? So this is kind of a special case. So this means that we're going to have infinite solutions. That means that if you had a number line, you'd have it colored both ways, shading both ways. Nice, neat, artistic. So that means it goes from negative infinity to positive infinity. So I write the interval notation from negative to positive infinity. Okay? Again, rounded brackets at the infinities because you can't reach it. If this would have been a false statement, we would have had no solution, and we'd call that empty set. So we'll see what happens if we come across that. And again, I didn't follow directions, so hopefully you can get along with the notes. All right, same type of problem. Highlighter. What are we distributing over the parentheses? Don't forget the negative sign. That's a big error. So here, so that's negative 2x minus 8 is greater than x plus 10. This looks very similar to the last problem we worked on. Probably is. We just didn't flip the sign. Okay, so let's do it. We did the same thing we did. Subtract x from both sides. Add 8 to both sides. These cancel. These cancel. So 0 is greater than. Those cancel. 0 is greater than 18. Is 0 greater than 18? Not this week. So this is a false statement. Okay, it's a false argument. So if I had a number line, there's nothing I could put on the number line that would make this true. So we just do the fancy brackets like this. And you have a 0 with a kind of a diagonal slash through it. And this means empty set. It means there's nothing of our set of numbers that can be plugged in to make it work. Okay, again, false means there's no solution. So just trying to put some terminology that you might have thought about hearing or heard in other classes, but that's basically how we did it. And lo and behold, guess who didn't follow directions again? I'm kind of doing that on purpose, but I hope you find it okay. Okay, solve the compound inequality. Compound inequality means that we're going to have two sets of inequality signs. So we have three parts to this problem. So we have this part, we have this part, and we have this part. So there's three parts. I hope you see all the three colors. So the middle part, the 3x minus 6, goes with both parts. So we're going to break this into two problems, and the middle is going to go with both. So first problem is 3 is less than or equal to 3x minus 6. And my second problem is going to be this one. 3x minus 6 is less than 12. So now we have two different inequalities. So we can go ahead and start solving it. Okay? So working out this first problem, I think I'd say let's add 6 to both sides. So I'm going to get 9 is less than or equal to 3x. Divide each side by 3. So 3 is less than or equal to x. And then sometimes it's not as easy to read it. We might put it back together. I'll flip that so I can kind of think what the picture would look like, because I can't make it always work in my mind. Remember, if the variables first, the arrow points to the direction you'd be shading. So overall, I'm going to probably use this part as my answer, but I'm going to use this part to draw my number line. All right, let's figure out this second part. So I'm going to add 6 to both sides. So I get 3x is less than 18. Divide each side by 3. So x is less than 6. Okay, so I remembered I have a number line somewhere down here. Yay. So I want This is why I can't have nice things. All right. Let's say we have 0 here. We have 3 here. We have 6 here. All right, so I want values that are greater than or equal to 3, so that's going this way, or less than 6, so that's an open dot going this way. Okay? So we can go ahead and look at this. There's no reason for me to do this because I want the interval notation of this now. So my interval notation says, hey, I start at 3. It's a square bracket because I have a solid dot. And I go to 6 because I want this region in between these. I go to 6, and this is going to be a rounded dot because that would have been a rounded bracket because it was an open dot. That's my interval notation. This is also a compound inequality, even though we have the word and in there. It's just we have compound just means we have 2 inequalities in the problem. So let's work this first one out. Subtract 2x, subtract 2x, add 8, add 8. So that's going to give me x is greater than, those cancel out, it's greater than 11. Okay, sounds good. Now I'm going to add 5 to both sides. So I get x is greater than or equal to 13. All right, let's put this on a number line. So if I had 0 way down here and say 11 here and 13 here, I have an open dot going this way, and then I have a solid dot going this way. Okay, notice my arrows going the same way. So there's a term in there, the word and. That means that the graph and is going to stand for, if I were to plug a point in, it has to work on both. Okay, this and that. If me and my friend went to the store, both of us went to the store. If me or my friend went to the store, we both went to the store, or one of us or the other went. So the word and is going to be crucial in knowing how to do this. So what we have to think about is, let's bring that highlighter back up. So if I talk about this part of the problem, we're at an open dot going this way. If I talk about this part of the problem, that's a solid dot right there, and that's going this way. So they overlap here. See where that got nice and dark? That's where the 2 graphs overlap each other. So I want to include that overlap. So our graph, to find a point that works for both problems above, would start at square bracket 13, okay, because it's a solid dot. Remember that, there's a solid dot for that, to infinity. Well, what about like 11.1 and 11.2 and 12 and 12.1? They're not part of the problem. They don't satisfy both answers. So this is how we're going to write. So you find where the leftmost would be on this problem, or the rightmost if it was shading the other way, and go with that. That green is our interval notation. Okay, solve each compound inequality. Oh, so we're same idea. We're going to solve this. Again, we have the and statement. Remember, and is going to mean we have to find where it works for both. So add 5, add 5. So 2x is greater than 20. X is greater than 10, right? What did I do? I divided each side by 2. Okay, and then I'm going to add 5, add 5. So I get x is less than or equal to 7. So let's think about this on a number line. I have 7 here. I have 10 here. Again, 0 is way down here. All right, so I have an open dot at 10 and it's shading this way. Agree? What is this? Well, it's solid dot. I want values less than 7. Okay, will the red and the blue lines intersect each other? The answer is no. This is not an and problem. If I had the word or there, totally different problem we could work out. I don't have the word or, I have the word and, so I have to satisfy both cases. So my interval notation on this one is going to be this, with that 0 with the slash through it. You have to be able to draw those really fancy brackets in order to pass this class. I'm just kidding. I got lucky drawing them that quickly, but all right, so empty set is our answer to this one, and I'll just put the word empty set. You don't have to put that for an answer. What I would put for an answer for this problem is this right here, and that's completely understood. Some people say, hey, can I just put this? And I've seen that in books as well. These are supposed to be the brackets where there's nothing there. And that's fine. It really becomes up to you. You know, I would accept both answers. All right, the word and. Okay, we saw one that got goofy last time, right? All right, so let's do this. Subtract 5, subtract 5. So I get 1/4 x greater than or equal to -3. Multiply side by 4. So x is greater than or equal to -12. Okay. Same thing on this one. Let's see, subtract 4, subtract 4. So I get 2/3 x is less than or equal to 4. Multiply by the reciprocal. I'll change colors so you can see that. Remember, the reciprocals that flip over the fraction, so those cancel nicely. X is less than or equal to 4 times 3 is 12. 12 over 2 is 6. All right, so I have -12 down here, say 0 here, and I have +6 here. Let's just pretend I can space really well. So this is going to say I want values including the -12 going this way. And this part says, hey, I want to include the 6. I want values less. So now we're talking about the region in between. Okay, they're both solid dots. Okay, so we're going to include the endpoints, which is great. So my interval notation will go from -12, and it's going to be a square bracket because I include it, up to 6. And that's also a square bracket because those are both open dots, or excuse me, both solid dots. They had the equal sign with both. All right, this one just gets silly. What do you think we should do? And we have the word or in there, which is fantastic. What I'm going to do is I'm going to multiply everything times 10. If you paid attention in 4th grade math, you realized if you multiplied by 10, the decimal moves one place to the right. Okay. Notice we have a new word, or. Or is not the same word as and, agree? So let's go ahead and solve this. Add 6, add 6. So I get 4x is greater than 20. Divide by 4, divide by 4. X is greater than 5. Okay, there's one answer. And then this one, I'm going to divide both sides by 2. So x is less than 3. All right, let's put these on our number lines. So I have 0 here, I have 3 here, I have 5 here. I guess we have 2 number lines, so I could have done them separate, but I just choose to do them on here. So I want values open circle greater than 5, open circle because I don't include it, and I also want to have an open circle going this way. Okay, what happened when this was the word and right here? That meant it was an empty set. There was no solution to the problem. But we have the word or, so this or that can work. Okay, so let's write this. That's going to negative infinity. That's going to positive infinity. So my interval notation is going to kind of have a lot to it. It's going to go from negative infinity, because I read it from left to right, to 3, rounded bracket at 3. Okay, it's rounded bracket at 3 because I don't include it. And then I have a rounded bracket at 5 to infinity. So I have to have both parts in this problem for the compound. The reason that works is because the word or is in there. If I pick a point down here, it'll work on one problem or the other. If I pick a point up here and I plug it into both the problems, it's going to work on one or the other. Okay? More or statements. So I have 5x, add 2 to both sides. I'm going to kind of go a little quicker through this. Divide each side by 5, so I get -1. And this one, I'm going to subtract 2x. I'm going to add 8. So I have both of those. Let you catch up with it. This is an or problem, so it's going to work out nicely for us. So I have -1 here, 0 here, 3 is over here. So take a look at this one. I have an open dot at -1 going this way. I have an open dot at 3 going this way. What does this problem look like? It looks like an AND problem. And one thing that we have to really understand about these number lines is those arrows mean they're going forever in a certain direction. So on this one, open dot going this way. This one is an open dot going this way. Okay? If it was an AND problem, I'm looking for that really dark color. But it's an OR problem. So an OR problem means, hey, all these values would work on one or the other. Even the open dots would work. So the -1, if I plugged it into the other equation that got the 3, it would work. The 3, if I plugged it in the equation that gave me the -1, it would work. So this is an OR problem. So this is going to go to -infinity. This is going to +infinity. And let's change pens. So my interval notation is -infinity to +infinity. Okay. Remember both rounded brackets on that because we can't get to infinity. Let's see how many more slides I have. Oh, this is the last one. Good. All right. OR problem again. Add 5. So if I add 5 to that, I get to what? 24. Divide by 6. Add 8. Divide by 2. All right, think about what this looks like. If I have 0 here, I have 4 here, I got 10 over here. So then I have an open dot at 4 going this way, and then I have an open dot, or a solid dot, excuse me, solid dot at 10 going this way. What kind of problem is this? Is it an AND problem or is it an OR problem? Well, it's OR. Remember, OR, we have to figure out a value that works. So I'm going to do this. All of these numbers here, if I plug in, are going to work, including here. So because I have the word OR, where would this be starting from? It would start at round bracket 4 and go to infinity. There's only a single one that you list because remember, OR, if I were to pick, say, 5 and I plug 5 in, 5 works here, okay, doesn't work here. But the word OR, if I plug in 6, it works here, 7 works here, 8 works here. Think about if I pick 20, 20 works here, and 20 works here. So the OR, you need to have a true and a false, or a false and a true, or a true and a true. Okay, that's for your OR. Your AND has to be true, true. We could talk more about that if you want me to clarify that. Okay? All right, we are all done with our second lesson.